Hello everyone, this is Michael Spivak textbook. We're going to read it together and problem solve together and address the questions we have along we read the book. So we started from we finished last time on problem 3, number 2. So we're continuing on number 3, 4, 5, 6 in this video session. The number 3 is just to start off is similar. Some of the questions that we have to address is part of this question, but we'll go over again and see the implications. So let's dive in. So let's go to the note section, Spivak calculus. Okay. So first of all, AB inverse is equal to A inverse times B inverse. Okay, so all we need to prove is AB inverse times A times B is equal to 1, right? Because that is exactly the same as okay, let's approach it this way. Let's do it one by one. AB inverse is let's do this way. Okay. AB inverse times A times B it doesn't ring to me quite clearly yet. Let me get back to you. Just a moment. Okay, so what this is equal to is it's equal to 1 times AB inverse, meaning we can do whatever with 1 here. A times A inverse, B times B inverse, times AB inverse. So if we shuffle this a bit, which we can because of commutative laws, 8B times AB inverse is equal to A inverse times B inverse, which then is equal to, this part of it is 1 because AB times AB inverse is 1, right? So A inverse times B inverse, which is equal to A inverse times B inverse. QED. All right. Now A over B, this is problem 4. AB times C over D is equal to AC over DB if BD is not equal to 0. Alright, so BD is not equal to 0, so we can definitely divide by B or D. So let's remove this. So we start from a clean slate. This is equal to A times B inverse times C times B inverse, D inverse, right? So if we can shuffle this a little bit by associativity and commutativity. B inverse times D inverse, and this is equal to AC times BD inverse. By what? By the things we just proved, right? So these are related, and we can use this fact to prove 8 AC equal times the A over B times C over D is equal to AC over BD. QED. All right. Now number 5. A over B, big division sign, over C over D is equal to AD BC. Okay, let's see, remove the fact that we need to prove and see if we can get there, right? All right, so what does this division mean? It means that A over B times C over D inverse, right, is equal to what? A over, this is, again, we can do like this. A times B inverse times C times D inverse, -1, which is, now we can shuffle this into A times B, -1, B inverse, C inverse times D inverse of inverse, right? We don't know what this is yet. Let's not assume. Which we can shuffle this into A times D inverse of inverse times B times C inverse, right? Alright, so we cleared this part, but we haven't figured out what D inverse of inverse is. So let's prove this now. D inverse of inverse is equal to, in fact, equal to D, right? Let's prove this. Proof. Suppose we have let's do this. D times the inverse of inverse is 1 inverse, which is 1's inverse is just 1, right? Because 1 times is 1, so 1 is itself its multiplicative inverse as well. So that means that we have the inverse times the inverse of inverse, right? Because of this fact. This fact over here, we can expand the inverse like this, right? So now we have the inverse times the inverse of inverse is 1. So we can deduce that the inverse of inverse, in fact, is equal to D, because D inverse is inverse. We can D's inverse, D times D inverse is 1, so D inverse of inverse is equal to D. QED, right? If there's a logical fallacy in here, please let me know. I'll dig in further to polish this a little bit. But that's a fact. So let's go back to the thing we had to prove. So A times D inverse of inverse is this. So we have this. So this is A times D over B times C. QED. All right. Number 6. All right. So if D is not equal to 0, then A times B is equal to C over D if and only if AD is equal to BC. Also, okay, let's prove this first. So because it also asking us to determine when does A over B is equal to BA, but let's do this after proving the first one. Okay, proof. So suppose let A over B is equal to C over D, then A times B inverse is equal to all right, let's do this. We know these are equal, so when we divide A over B over CD, this is basically equal to AD over BC, right? This is, what that means is this is equal to 1, because we are just taking the inverse of, since C over D, dividing by C over D means this is equivalent to saying A times A over B inverse, which is again A over B times C over D inverse, right? So by the thing we just proved, this one, we can make this say AD is over BC is basically equal to 1. Well, the fact that we can say it's 1 is because we're taking the inverse, right? And what this is equal to is just AD is over BC, right? So since AD over BC is equal to 1, AD times BC inverse times BC is equal to BC, right? So then we can say AD is equal to BC, since the last two terms are equal to 1. So we proved the one way, and let's prove the other way. Let AD is equal to BC. Then what happened? AD is equal to over the inverse BC times the inverse, which is A is B, C, D inverse. Now A times B inverse is equal to B, C, D inverse times B inverse. So that means that A over B is equal to, we can remove this. I don't really like to say remove something by the elementary learning we just did, but by commutative law, we can switch this around to remove, to understand that B times B inverse is equal to 1. So what remains is C times B inverse, which is again C over D. C over, different things have been moved around. So if you move this around, switch this place from C to B inverse, then we can multiply B times B inverse, which becomes 1. So we can ignore that, and then it's C times D inverse times C, which is C over D. So QED. All right. So we can determine also when does AB over BA, right? This is such a weird question, right? When does it equal? So I think we can use the fact we will just prove now. So if AB AD, then AD equal BC. So now we can say, when does it equal? If they're equal, if A times A is equal to B times B, then we know that A over B is equal to B over A, right? Yeah, I think I just used the statement backward. So I have to say that if AD is equal to BC, then A over B is equal to C over D, right? So using that fact, if AA is equal to BB, then C over B is, A over B is equal to B over A, right? So what does that mean? It means that A squared is equal to B squared. Does that mean if A is equal to minus negative plus plus or minus B, right? Am I right? Yeah. So let's see. Well, if yeah, let's see if we can find a better answer than this. But for now, my understanding is that if A equal to if A is equal to negative or plus positive or plus minus B, then we can say A over B is equal to B over A, right? So thank you for watching. Let's get to problem 4 next time. See you next time.